Hello, good morning, sixth grade scientists, and welcome to science class. All right, hope you enjoyed trying to figure out what in the heck was going on in that aquarium Mr. Gladwell was showing you, and how and why was that happening. And that had everything to do with explaining weather, and that's what this current unit we're going to be dealing with here today. And so, why don't you go ahead and pull out your science journal or a paper, some paper that you're writing down things that are important you'll need to use for later for science class. There's some vocab we might want to write down for later. And by might, I mean you should. All right, in case you're wondering. What is weather? Well, weather is just what is happening right now. What are the current conditions in the atmosphere? So if you look at this picture here, you can see that there are certain conditions in here. All right. As well, if you look behind me, we can see partially cloudy um, skies. We have some slight wind. Um, you can see up in that oak tree, there's some slight wind as well. It's just the current temperature, how much humidity, how much water is in the air as well, and what's the air pressure. Um, uh, how is that affecting what's currently happening? Which is why we kind of joke about how the weather forecasters on the news are so wrong. Well, it's just because the weather changes constantly as well. Go, look out your window right now. It's probably different than it was last night. It's probably different than it's going to be tonight, and it's gonna change. So we're in springtime, so it's a little chilly still in the mornings. We're in the summer times, right? And it's not. So it's just this currently what's happening in all the air around us and those layers of the atmosphere that we talked about um, in your bell work here a few weeks back. All right, so weather is what's currently happening. So how do we figure out what's going on? Well, we look at these versus air masses. And an air mass is just a whole body of air with similar temperatures, humidity, and air pressure. So go ahead and write that down. You can pause the video if you wanted as well. So here's a picture of a cold air mass. Notice that it's all circles. This is like a big chunk of air all stuck together, right? All stuck together. Um, and it all moves together, right? Because it has the same um, these same traits: similar temperatures, similar humidity, similar air pressure, clumped together, and it's all moving together. Right? It's just everybody's kind of moving and rolling together, almost like a flock of birds you see flying in the sky, where there are like hundreds of thousands of birds, and even though they're each individual birds, they kind of fly together, and you'll see sometimes they'll turn and they'll move and they'll flow, almost like something's being poured. Um, that's what air masses are like, right? And that's how we describe those. And the front is the place where those two things come together. So here's one type of air mass, and then here is another type of air mass with different temperatures, humidities, and air pressures. And the front is just the boundary where those two air masses meet. Weather is all about these air masses moving around the atmosphere. All right. So, what kind of air masses do we have? Well, we've got quite a few different ones. All right. We have continental, which are dry. They're dry because they are over land. All right, and evaporation can't happen as well, except over oceans. So that's dry. There's not as much evaporation that's happening. Maritime is means over water, so that's going to be wet because you have lots of evaporation happening as well. Polar, I mean North Pole or South Pole, they are tipped away from the sun, so you're going to see less thermal energy. And tropical is going to be near the equator, between the Tropic Cancer and the Tropic Capricorn. So just the kind of the middle like belt around the Earth, and that's going to be warmer, and there's lots of water there, and warmer air will hold more water as well. So they tend to be that. So we have our little signals here, um, and so maritime polar would be these that are in a northern region, but also over water. All right, our CP is our continental polar. This is going to be our over northern areas. All right, colder and drier because it's continental. All right, because there's not much water to be pulled off the ground. All right. Then we have our maritime tropical, which is ocean, so over water, but it's going to be in a tropical area. So it's going to be warm and a lot of water, right, as well. Um, and then our continental polar, which would be this one here. So we're in the tropical area, lots of land on overland as well. So it's gonna be hot and dry conditions. All right, as well. And these are the different types of air masses, all right, that we'll be dealing with as we look at air masses, especially air masses over the United States. In different areas of the world are going to have different ones. We're going to be mostly talking about these air masses because eventually we're going to have to be predicting what's going to happen to the current conditions in the atmosphere, the weather, based on these air masses. And these are the most common ones that we see, and they move mattering the time of the year as well. All right, so what about this space in between all these air masses? All right, and that's what fronts are, right? And before we get into how they move, I want you to look at this picture here. All right, so this right here is just a graduated cylinder, and it has oil on the top, and it has food coloring and water on the bottom. And you can see this specific line here between these, like two air masses. They have different densities, and that's why they line up in this way. So if I take this and I tip it, you can kind of see that it still wants to stay separate because of the different temperatures, humidities, and air masses. And mostly here it's density. And density is obviously part of that. In fact, so much that if I try to mix these, they just don't want to mix, right? Don't want to mix at all. And that's what these air masses are similar to, right? Oil and water is a great example to show. They're just going to want to try to say separately as well. All right, so in the continental U.S., air masses are commonly called westerlies because they're moving from the west to the east. And then jet streams are just like these rivers of air that move very quickly. And you have polar streams. You notice that they are cooler, but more importantly, they are in northern areas. And then the subtropical are going to be ones that are more south towards the tropics, right? As well, they usually don't move quite as fast as well. So there is a video to watch. Here it's going to give a little more descriptions of the jet streams, and the jet streams are one thing that help push air masses certain ways. Is doing that. All right. So go ahead and watch the video. All right, and then I'll have some instructions for you at the end.
This episode of D-News is brought to you by Squarespace. Surfers think catching a gnarly wave is radical? Well, thanks to some science, we can ride air currents at almost the speed of sound with 200-ton surfboards in the sky. So how's that for radical? Hey Silver Surfers, Julian here for D-News. British Airways Flight 114 recently made a transatlantic crossing almost an hour quicker than usual and was clocking ground speeds of 745 miles per hour or nearly 1200 kph. It's been making news because that is a frankly ludicrous speed, considering the speed of sound at that altitude is somewhere around 1100 kph. But when you take into account the airspeed, that is, the speed the airplane is traveling through the air around it, instead of the ground speed, it doesn't actually break the sound barrier, which is a good thing because the Boeing 777 really wasn't designed for that. Fortunately for everyone stuck in coach, the aircraft was riding a particularly ferocious jet stream that was at times over 320 kilometers per hour. But why do we have jet streams? First of all, jet streams are not unique to Earth. We've observed them on Jupiter and Saturn, and here on Earth, jet streams form in the troposphere, the lowest atmospheric level. And there can be many that swirl and flow and join and split, and most of them head from west to east. So, if you've flown from North America to Europe, you've probably noticed your flight is shorter in that direction. The one you and Flight 114 cruised on is the Northern Hemisphere's polar jet stream. Now, the polar jet streams are from 7 to 12 kilometers up, but each hemisphere also has weaker subtropical jet streams that are 10 to 16 kilometers up. Jet streams form at the boundary layers between warm air and cold air. The higher pressure cold air pushes into the low pressure area, and in the winter, the pressure differences are greater, so you get stronger winds. But the wind doesn't just move in a straight line from the pole to the tropics because of the Coriolis effect. Basically, the planet spinning underneath the moving air deflects it east. Higher in the troposphere, there's less friction, so these winds can go unbroken for thousands of miles, and voila, jet stream. Throw in modern air travel, and if you're lucky, you can get where you want to go at almost the speed of sound. Speaking of getting where you want to go, this episode of D News was brought to you by Squarespace. Squarespace recently launched their latest version of their platform, Squarespace 7, which has a completely redesigned interface, integrations with Getty Images and Google Apps, new templates, and an incredible feature called Cover Pages. Try the new Squarespace at squarespace.com/dnews and enter our offer code DNews at checkout to get 10% off. Squarespace. Start here, go anywhere. Now, if you don't think I've gone basic enough to explain why there are jet streams, Trace explains air itself over here. Also, you were probably one of those kids who kept asking why all the time, huh? Well, I like it, keep it up. So, planning a world trip, would you head westerly to ride the current or east to west to feel like a time traveler? Tough call, but for me, I like cruising into the sunset for hours at a time. Let us know in the comments, and I'll see you next time on D News.
Hey guys, I'm back. Hope you enjoyed that video talking about the jet streams and how we could use the jet streams to help us as well. But mostly, honestly, the jet stream is, for our purposes, this is how we move air masses around, and those air masses then go over different areas and change the current conditions. All right, in in the atmosphere. All right, so now what you can do is you can go to Google Classroom, and there are going to be a little custom review Google form for you to go through. If you get something wrong, it'll tell you, and then you get to review over weather and air masses, and it'll give you another chance to get the correct answer on there. And that's and once you submit it and turn it in, it means you got everything done and turned in. If you do miss it, feel free to go back and look it over. Remember, weather is the current conditions. Air masses are these masses of air that are very similar, that kind of stick and move, right, and move together as as well. So tomorrow, Mr. Gladwell is going to get into fronts and these borders between, and that is the most exciting part of weather. That's where all the action happens, are when these two pieces come together. They are the reality TV of weather, right? We watch it to see craziness and ridiculousness, right? As well. So good luck with the custom review, and look forward to learn more about weather from Mr. Gladwell tomorrow.